This video is for statistics, section 7.2, estimating a population mean. There are 4 questions in this example. So the first question is asking you plan to construct a confidence interval for a population mean. Use the given data to determine whether the margin of error should be calculating using z alpha over 2, t alpha over 2, or neither. In order for us to fit using z alpha over 2, this is where sigma is known. For us to use t alpha over 2, this is where sigma is unknown. And if you want to use neither, this is used when your population is not normally distributed and the sample size is less than 30. So for question, and then you have to use a 95% confidence interval. This means that your alpha is going to be 0.05, which is in this case 5%. So for question A is asking us that if n sample size is 9, x bar is 75, which is sample mean, sigma is unknown, and the population has normally distributed. Since sigma is unknown here, so this is going to be z alpha over 2. Although the sample size is small, but the population is normally distributed. So for us to do this question, when sigma is unknown, we have to use t alpha over 2. So in order for us to use t alpha over 2, you have to use qt. And 1 minus alpha, which is 0.05 over 2. And the degree of freedom in this case will be n minus 1. So n minus 1 in this case is your sample size minus 1. So your answer in this case came out to be 2.306. For question B, your sample size in this case, let me write it down here, this will be t alpha over 2. For question B, your sample size is 5, your sample mean is 20, sigma is known, and the population is very skewed. So for this question, it will be neither. The reason why it's neither is because the sample size is small and the population is not normally distributed. For question C, the sample size is 12, your sample mean is 98.6, sigma is known here, and population is normally distributed. Since sigma is known, so we will be using z alpha over 2 for this question. Although your sample size is small, however, your population is normally distributed, so this is not a neither case. So for this case, we will be using z alpha over 2. So in order for us to calculate this critical value, we will using qnorm of 1 minus alpha over 2. Again, our alpha in this case is 5%, which is 0.05. So qnorm 1 minus 0.05 over 2. So that will give us 1.96. As a rule of thumb, your rounding is around 2 to 3 decimal places. And for the last question D, your sample size is 75, your sample mean is 98.6, sigma is unknown, the population is skewed. Now because the sample size is big enough, so your answer is not neither. So it's either z or t alpha over 2. But since sigma is unknown, so for all sigma is unknown, we will be using t alpha over 2. So in order for us to figure out what is your critical value in this case is we have to use qt. Formula is qt 1 minus alpha over 2, which is 1 minus 0.05 over 2. And again, your degree of freedom in this case is 75 minus 1, n minus 1. So that will give us 1.99.